Hi children and hi everyone. In previous video I explained about the net force and free body diagrams and Atwood machine. So up to now you didn't saw that video, then go and watch it once. So children, up to now you didn't subscribe my channel, then go and subscribe my channel. If you want more videos from me, then subscribe the channel, comment their videos and share their videos. Okay children, now I am going to one more topic in this one. Very easiest topic, I think so. So that is very important. Already we learned about the Newton's first law and Newton's second law. Now we are going to Newton's third law. Newton's third law of motion. Newton's third law of motion and examples. Very easiest topic. So here now, what is Newton's first law of motion? Every body will continue its state of rest, state of uniform motion until some external force acting on the body. That should be called Newton's first law of motion. And what is Newton's second law? The external force acting on the body is directly proportional to the rate of change of momentum. That is what we call Newton's second law of motion. And now Newton's third law. For every action there is an equal and opposite reaction. For every action there is an equal and opposite reaction, and simply in terms of mathematics equation we can write action is equals to minus reaction. So this is known as Newton's third law of motion. For every action there is an equal and opposite reaction is there. That should be called Newton's third law of motion. Action is equals to minus reaction. So in our lives we will saw so many examples. For example, here just imagine one lorry is there and one car is there. Here they are coming towards each other. Two vehicles are there, one is car, one is lorry. Both are moving towards each other. So just imagine if they can collide each other, they are collided each other. Here simply when two vehicles are going to be collide each other. Clear? My question is here one vehicle is damaged or both vehicles are gets damaged? One vehicle is going to be damaged, or I am not asking about which one is gets more damage. Simply my question is when any accident is happened in that how many vehicles will be damaged? Yes, both should be damaged, because when both are collide each other, one should be applies force on next one also applies force on this one. That means car also applies the force on lorry also applies the force on car. Both are simultaneously applies the forces on each other. So for example here car can applies force on lorry, can applies force on car can also applies the force on lorry. If it is one action, next one is reaction. So like that, for every one object should be in action, next another should be in opposite reaction. So this is called Newton's third law of motion example. For every action there is an equal and opposite reaction. So next we know that we are throwing ball onto the wall. We are just taking a rubber ball and that should be thrown onto the wall. So we applied some force on wall. So due to that, here we apply some force on wall. That means that is action. Again the ball is bounces back. The ball is bounces back. When we throw a ball onto the wall, that is the action. But the ball is coming in back. That is the reaction. In which direction that is coming? In what v direction we applied, in opposite to that, there should be come back. So this is the one of the another example. Clear? So we are applying the ball on, we apply some force on the wall with ball. On the ball, again wall also applies the force. That is equals to action equals to minus reaction. In the same manner here, for example, here one block is there and this is another block, some A and B. You can take spheres also, you can take. Clear? When both are in collision, there is some interaction, between them. Here B can apply the force on A also applies force on B. I am writing now B F B A. That means what? Force on B by A. Clear? I am writing now F A B. Force on A because of B. So from that what right here, FBA is equals to minus FAB. Here same thing I am taking now. Here the interaction between the two objects I am saying now here, both should be collided. Here it means what? Force. In collision or in bombarding, one body should apply the force on another one. That's why here, if you can push this block, A can push the B, A can push. For example, here just we are applying the force. Just we are moving this one. B can strike the A also again opposes the B. Clear? And here one ball is there. Here A and B are there. When they are collided, during the collision, I told you in car and lorry example. During the collision, one should be applies the force on another one. Like that. In this case, two spheres are there, or we can take two blocks are there. If they interacted by colliding them, then one should be applies the force on another. That is the example. Here, what I am telling here, FBA. In this action, in this example, A can apply the force on B, B can also apply the force on A. Here I am writing that one. FBA, what? Force on B by A, and FAB, force on A by B. Clear? So what it is? FBA I am taking, that is action, and this is what? Reaction. Clear? So tell me now here, FBA, force on B by A. A can apply the force on B, that is the action. Clear now? And FAB means what? Force on A by B. In this example, you have to observe action and reaction must be in pair. Action and reaction must be in pair. That means action and reaction never belongs to on one body. They should be belongs to system. Clear? We applied some force on the wall by throwing the ball. That means on that wall some force is applied by the ball. Again the ball is coming back. That means what? On ball also wall applies the force. Clear children? That means ball applies the force on the wall, wall also applies the force on the ball. That means action is on one body, reaction is on another body. That's why what I have to say, action and reaction must be in pair, not single. That's why here action reaction not on one body. Nobody can cry by beating himself. Got my point? If you can slap ourselves and we can cry. No. If you can someone beat others, then we will cry. Or if you can beat others, they will cry. Clear? Got my point? In this way, action and reaction should be not on one body. They are different bodies. That's why action reaction must be in pair. Clear, children? So this is simply about the Newton's third law of motion. What is Newton's third law of motion? For every action, there is an equal and opposite reaction. So action is equals to minus reaction. This is what we call Newton's third law of motion. For example, what you have here, when two blocks A and B are in interaction, then they have forces like this. FBA is equals to minus FAB. So in that, FBA is the action, minus FAB is the reaction, children. So here in our daily life examples, some examples are mentioned in textbook. Here, flying of birds. Why the birds can fly easily? For that also he was given example. First thing is flying of birds. Flying of birds. In this case also Newton's third law is applicable. Flying of birds. To fly the bird, for flying the birds, they will push the air in downwards with their wings. You can observe the birds can pushes the air in downwards. That is the action. The air which is went downwards, that can pushes the body in upward. That is the reaction. Clear, children? The first example is what? The birds can flying easily because of Newton's third law. Why? Because the birds can fly. How? They can pushes the air in downwards with their wings. They can push downwards. So when the air goes under, that should be having some pressure, and with the same pressure they can pushes the body upward. That's why in this case also Newton's third law is applicable. And next thing is swimming of the person. Swimming of person. So we can observe while the persons are swimming in a swimming pool. Simply you can observe they can pushes the water. In previous example, birds can pushes the air in downwards. Now a swimmer can pushes the water like this in backward. They can pushes the water backward. For example, here it is the pool. In that the person is swimming. Clear? So here the person is pushes the water in backward. Pushes the water backward. The water which is went to back, that should be again pushes the person in forward. Clear? He is the swimmer. Who is that? He is the swimmer. Just imagine. So hands. So he was swimming in this direction. During that he can pushes his hands backward. He pushes the water in backward, and water can pushes the person in forward. So swimming is also possible because of Newton's third law of motion. And so next thing is we have launching of rockets. How the rockets can move. So they are also application of Newton's third law of motion. Symbol. This is the rocket. So in a rocket we have so many chambers with fuel. So many chambers with fuel. So when the fuel burn, look here at the diagram. When the fuel is burned, the hot air should be goes down. We can observe in case of vehicles, some smoke is coming with backward through the silencer. Like that, in case of rocket, huge fuel is there, huge amount of fuel is there, that should be burned. So when the fuel is burned, some gases are coming outside. They should be called as exhausted gases. What it is? Exhausted gases. These exhausted gases are coming with certain velocity in downward direction. That is the action. With what amount of velocity the gases are coming down, the same gas should be again pushes the rocket with the same speed. So with what velocity the air is, if exhausted gas is coming in this direction, with the same velocity the rocket will be goes in forward direction or upward direction. So in this way we have a lot of examples for Newton's third law of motion. You can observe in our daily life, so you will find so many examples for Newton's third law of motion. So just you can check your surroundings and you can observe. For example, one spring it is there, one spring. So here if you can press the spring, that is the action. Clear? That means we are applying the force on the spring in downward. That is the action. And once you can separate this one, coming back. So like that is the reaction. So in this way children, you may know that Newton's third law of motion. For every action there is an equal and opposite reaction is there. Action is equals to minus reaction. This is what we call Newton's third law of motion. You have to remind that this point is very important. Action and reaction must be in pair. Action and reaction does not belongs to a single object, that should belongs to two different objects or system. So children, this is about the Newton's third law of motion. Based upon the Newton's third law of motion, one balloon activity is there in our textbook. So many examples are there. So once we will go for that also in the next videos. Children, I hope you understand. If you can understand this topic, like and share, comment the video and subscribe my channel and press the bell icon to get the notifications. Thank you children. We will meet in the next video with next topic. See you later. Bye. Take care.